if you want to compute the marks from 90, I guess they will look like divided by 90, and maybe 100 is multiplied here. I guess maybe the formula, I guess that's what it is, I guess. Let's see. So now if you see D, there will be another column that is there, and it does something else anyways. I mean, it does something that yeah, so something anyways. So we have just, I mean, we've just computed this. We just found, we just inserted that column inside that. I mean, that is a processed version of these kind of values. Maybe we have added this column in a very wrong way, and later on we suggest that, okay, we should delete that column. Well, that's very simple. Again, using the concepts again, just like the dictionaries. Delete this, and this column is deleted from data, and you're again with the data that you had. So you can add columns, you can delete columns, and indexing is really fine. I mean, indexing like masking. Let's say you want to pick, for example, or you want to pick the data frame such that you want to pick all the records such that the marks are greater than, let's say 70. You want to pick all the records where the marks are greater than 70. This is that simple. All the data will be copied into G with this condition, and this condition can be arbitrarily complex using ands and ors and combinations and all that stuff. And you have seen this kind of stuff in NumPy as well. I mean, this is called masking. Great. So that's available in Pandas as well. Okay, so that's how you can index. In the next video, I'm going to basically show you one type of problem that normally happens in real data, that is the missing value problem. Sometimes you read a data and some of the attributes or some of the row column pair values, they are just missing. I mean, they're not available due to certain reasons. How can you handle those values, and how actually Pandas suggest you to handle those kind of missing values, which is sometimes called NaN values or none type values also. They mostly used interchangeably in Pandas. So in the next video, we are going to handle or see how to handle missing data in Pandas. Hope to see you in the next video. Okay, in the last video we saw data frame object, and we saw actually how to add and remove columns, how to process data, how to index, how to actually mask, or how to apply conditions and selections in Pandas. We saw that very briefly, but in this particular video we are going to see one kind of missing value, sometimes called NaN, or not a number, or maybe not anything, or sometimes this none type, none, which is the default return type of any function in Python. This none type is also sometimes in Pandas is treated as NaN, or NaN is treated as none, or interchangeably anything. Let me give you what do we mean by that. Let's say we have two dictionaries. Let's say one dictionary is A with key value A, and the value is 1, then B and the value is 2. Okay. The other dictionary is B and C. So for example, that is one record with columns A and B. So A and B are the columns. On the first record, the value of A is 1 and the value of B is 2. Now let's say we want to insert another record in the same data frame. Now the value of B is available in the second time. The value of B is available, which is 3. And the value of C is available, which means a C column is added now. But for the value C, the first row value is not available. So we will say this value is missing here. But in the second row, we have 4. Similarly, the value of A is missing for the second row. And that is a missing value, which is sometimes called NaN. So these are missing values, and they are typical when you are working with data and you're reading data and you're getting data from somewhere, or large files and stuff like so. So pandas give some methods to handle these kind of this kind of situation. Let's say a equals pd dot data frame, again a dictionary. Let's say we have a 1 and b, let's say 4. That's the first row or record. The second record, let's say, is another dictionary. Let's say b is -3 and c is, let's say, 9. Let's say that's our data frame a. So now if you print this a, if you see the data inside a, you will see, oh, what's the problem? A is this and b, have we applied something in a wrong way? Let's see. Yeah. Oh, we have to create a list. That's the, okay, we have to create a list of it. We have to create a list of dictionaries. That's the proper way of calling it. So we missed just the syntax list of that. Okay, great. So now we have this a, we just call that a, and this value is missing and that value is missing. And in large data files, this is typical. I mean, there are a lot of values that can be missing. One way that Pandas applies to handle these missing values is to just fill these missing values with some fixed number. For example, there is a fill na function, and let's say you supply 0. That means wherever there is a not available or not a number value, fill that with 0, or maybe any value you want to fill that with. So that is one way to do that. And now if you see, the value of a is all the non-values are filled with that. Another kind of function that is available in Pandas that is sometimes used, that is drop na. That function drop na. What that does is it drops all the records that contain a missing value. Sometimes if that is feasible, I mean, dropping all the records that contain missing values, if that is feasible, then go for that. But if the missing values are a lot and they are spread over a lot of rows, then dropping all those kind of records, they will create a lot of data loss, and then it become really important how to handle these missing values. However, you can fill the missing values using fixed value, or you can drop them. And later on, we will see in scikit-learn that there are other ways of handling the missing values as well. You can fill each column, missing values in each column, using an average, or using, for example, a regression. There are ways to handle these missing values. But in Pandas, these two functions are right away there. You can fill all them with a fixed value, for example, or you can drop them and you are ready to go. Okay, great. Next, we are going to see, as I mentioned earlier, what is a confusion between, what if there is a confusion between implicit and explicit indices, and that I will discuss in the next video. Basically, just to give you a look and feel, what if the explicit indices you supply, they are 1, 3, and 5, and what if you call this particular command 1:3? Will it call the implicit index or the explicit index? That's a problem. So we will see, because 1:3, 1 and 3, they are also explicit indices, and whether this 1:3 is referring to the implicit indices that are default indices, or they are referring to these indices. So this confusion is there, and we will see how to handle that confusion using this lock LOC function and index lock ILOC function. We will see that in the next video. Hope to see you in the next video. Okay, in the previous video I mentioned a confusion that can be there if you have supplied the explicit indices that can conflict with implicit indices. In particular, for example, if this is the series object, or maybe a data frame object, if you want to, if for indices, let's just think about the series object. it has these values A, B, C with index 1, 3, and 5. If we, for example, access a particular element, let's say data with index 1, that means the explicit index for sure. But if, for example, we slice the values, for example, 1:3, the default behavior of slicing, if you give the numeric indices, that is to use implicit indices. And by implicit indices, we mean that what is at index 1? At index 1, this is B. So B will be printed, for example, or B will be fetched. And then you move to 2, which is C, then C will be fetched. And these are the values that will be printed. But the behavior might be different. You might be expecting to use explicit indices, which means access 1:3, and when the explicit indices are used, the last index is also included. And in that case, you might be expecting the index 1 is of A, so A should be printed, and index 3 is of B, and B should be printed. And this confusion might be there if this is there. So to handle that, there are two functions. One is called LOC, and another method is called ILOC. Whenever you call LOC, that means you are using explicit indices. I mean, you're forcing to use explicit index. And whenever you call ILOC, that means you're accessing elements using the implicit index whatsoever. So let's practice this and see the confusion. See the detail of this kind of confusions in here, Jupyter Notebook. So let's say we have a series object. Let's say A equals PD dot series. And let's say it has values as A, B, and C. That's the value. These are the values, and index as, let's say, 1, 3, and 5. Let's say these are the indices. Let's say this is A. Okay. Let's say we access A using 1. That means the explicit index, and that is this. Let's say we access using a slicing operator. Now this will use implicit indices, and it will access it will access these B and C, because 1:3 using indices, implicit indices results that. And we might be expecting that use this kind of stuff. So if we are really interested in using explicit indices, what should we do is we should call the lock function, aloc, and then 1:3. That means use explicit indices. That is to remove the confusions. Now it will use the explicit index 1 and 3. And if, for example, we are interested in using implicit indices, then it is good to use iloc function. Yeah. Now 1:3 is to use implicit indices, and the implicit indices are like these. So and like in series objects, you can do the same in data frame objects. Once you are using lock and iloc, then the further indexing inside these square brackets is exactly the same like NumPy. So whether you use lock or iloc, the indexing mechanism is exactly the slicing mechanism is exactly the same like you have used in NumPy. I mean, all indexing that stays the same. Lock means you're using explicit index. Iloc means you are using implicit index. Let's say, for example, we have our data frame, I guess D. That's our data frame available to us. Let's say I want to access D.iloc. Let's say I want to access the second row completely. The second record, the record that is indexed at, index at 2, which is the third row completely. Let's say I want to access that. Now this 2 is acting as, for example, if you see the second row or the row at the second index, which is the third row, that is completely this, and it returns that. Once you have used iloc, for example, and mostly people use iloc, sometimes lock is also required, but iloc is just to explicitly mentioning that I'm going to use the implicit indexing scheme. Again, you can consider whole that thing as a matrix, and once you have applied this iloc, then you're free to play with the indices like you play with two-dimensional arrays. For example, I want to, for example, I want to reverse, for example, all the rows, and I want to reverse all the structure. For example, let's say I want to do that, and you can see everything is reversed. I mean, all the indexing, like NumPy, all the indexing is there in Pandas. I mean, once you have used iloc inside, is just remember the NumPy indexing and everything like so. Okay, so that's the lock and iloc function. In the next video, we are actually going to just practice the Pandas to actually work on a data file that is saved as a CSV file. So we will show you how to actually manipulate, read, and write the data and play with the data, the real data that is there in some CSV file, and how Pandas will help you to manipulate the data very efficiently and very quickly. So hope to see you in the next video. Okay, in this particular video, I will be talking about a real data set. The data set I have chosen just to show you some functions that are available in Pandas to work on real data set. The data set I've chosen as a COVID-19 data set that was available in Kaggle, and it's a real data set that contains information of victims recovered, the total number of recovered people per country, per province, the total number of died people, and the total number of reported people per date available. That data is available. Let's see the look and feel of that data in a file, just to see what kind of data we are talking about. So let's say this is our data. This is a serial number column that contains the record number. That's a column called observation date. That's a date. That's a province or state. That's a country or region. That's the last updated, when the record is updated, what's the time, and how many confirmed cases were there at that date, and how many deaths at that date, and how many recovered at that date. As the date is moving on and on, you will be seeing that the number of confirmed cases and the number of recovered cases, they will be increasing. Maybe the number of deaths, they also increase. So let's see this data. Let's read that data using Pandas and do some manipulation of this data and see the look and feel of that data in Jupyter Notebook. Let's go to Jupyter Notebook and see. So first of all, I need this Pandas library. I imported that. Maybe somewhere I need this NumPy library as well. I'm also loading a scikit-learn sklearn library because I want to use the impute function just to handle the missing values. It is just more powerful to use the sklearn library. That is also a data science library, a package that is particularly a machine learning library or package that actually gives a better support or a larger support of handling missing data. Although here I have used this sklearn function just for an example, but I could have used this data frame fill NA function or something like so, but I'm just using that one. Okay, after importing all these, what I did is I just called pd.readcsv function and I load that data, and then I did this stuff one by one. Let's spend some time on all these commands one by one, and let's see in Jupyter Notebook what is happening. Let's go to Jupyter Notebook and actually read that file and do whatever we are doing here. So first of all, import NumPy that is already imported. Import, for example, Pandas that is also already imported. Then from sklearn.impute, import simple imputer. So let's use that, or let's do that. From sklearn.impute, import simple imputer. Okay, import that because that's a new thing. we need to import that. Now read the data, for example, data frame in df. So df equals pd dot read csv. There is a CSV file, read CSV, and it contains the path of the file. The path is located in my directory. It is located at this particular location, COVID, and the name of that is COVID_19 data. So COVID_19 data.csv. So let's read that file. The file will be read. If you just see that there is a function, let's say head, that gives the top records or the records that appear just in the very top. That's what the data file that I was showing you in Excel. It is showing just the first 5 records. I can show the first 10 records, for example, just by calling the head function in this particular way. Okay, great. Let's say I just want to remove this serial number because I think that is not required, and let's say I want to remove this particular column because that is also not required. There are multiple ways of doing that. I can call a del function on this, and I can call del function on that, but there is another way of doing that by df.drop, and in that you just give the columns that you want to drop. One column is serial number, I guess. What's the column name? That's SNO. So you want to drop that column, and then you want to drop this particular column with heading last update. So that is last update. So that is, I guess, what is there. Access1 in place true. So access1 is just mentioning do that stuff with columns. In place equals true. That actually is telling that whatever this operation you are going to do, reflect the changes in this df frame. If we do not write in place true, it will do everything and return onto a temporary variable or underscore variable or whatever we are saying, but the data frame will stay unchanged. So in place true means do that changing in df variable itself. So now if we see df dot head, let's say, it will no longer be showing us the serial number column and the last updated column. What next we can do, we may want to rename this name to just date, for example, this to maybe another. Let's rename all these columns using a rename function. df.rename columns equals to, and then we have that dictionary again in place equals true. So let's use this rename function, df.rename. Let's say that, and here we have columns, if I spell right, columns, and then that is dictionary. What columns you want to change? I want to change observation date. I want to change that to simply date, let's say, and I also want to change province slash state to simply state or province, let's say, simply that. And I also want to change this country slash region to simply country. So maybe I want to change this country slash region to simply to country, 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 and I want all that should be happen in place. So in place equals true. So after that, if you run that on this particular step, and now if you see the state of df, you will get like so. Okay, these many. So date, province, country, confirmed, deaths, and so on. So this is much nicer form than earlier. Moreover, we may have a lot of missing values. Oh, one way, this date format, the date format is not in a format that Pandas internal date format. So let's convert the date format into the internal Pandas date format using two PD2 datetime function. So let's say df date equals to PD2 datetime, and convert this df date in that particular format. And now if you run this df.head, you might be seeing the date format in a different way. See that? That's a date format that the Pandas is expecting. Now that is just showing some records. If you want to see more records, we can see those. Let's say I want to just count, or let's say let's just describe all the data. df.describe. There is a describe function that describe most of the statistics of the data. I mean, the total count of confirmed cases are these, the deaths are these, recovered are these many columns are there, these many values are there. The mean is that, and standard deviation is that, the minimum 25, and these are the statistics. Let's say there is another function, info, df.info. If you call that function info, it will give us the more information about the null entries and the non-null entries and so on. For example, if you see the total number of data columns are 6, the total number of records are 6162, the date entries is always available, the province entries are only 3700 available, the rest entries are null entries. So province entries, most of the entries are null entries and they are there. Maybe we want to drop those, or maybe we want to impute those entries and stuff like so. But there are null entries that are available in the province column. Some of the province values are no longer available. Let's see that here. For example, this is not available, this is not available, this is not available. And that's what the real state of the data is. This is not available, this is not available, and so on. So this can happen. Okay, next what we do is we actually use this simple imputer just to impute the missing values. One way is to do that using simple imputer from sklearn. Another way is, as we already know, just df.fill na with let's say not available, with let's say some string not available. That's it, that string. And with that, if you fill na using that, now after that we will be having all that data, the missing values will be filled according to, let's see some missing values, because in the province there were some missing values. Now you can see, for example, let me go on, yeah, so not available. We can use that, or we can use a fancy kind of thing that is available by scikit-learn and so on. Okay, after that, if you now see the information info, now you will not be seeing any null value. All the columns are there. Oh, this was not in place. So .fill na, that is, and let's change the df with it. So this doesn't happen in place. So df, just change the df. Okay, df changes. Now, if we now call the info, there is no null value anymore. Yeah. So I end this video here. In the next video, I will show you this group by command to just see these kind of stuff in a more detailed way, because this particular video is getting lengthier and lengthier. I'm stopping here in this particular location. Next time I will show you the group by command in the Pandas data frame, and I will show you what that does. So we will explore all that code that is written here, and we will in the upcoming videos, when we will see the plotting and Matplotlib, we will be using the same data file to work more and to get more insight how this Pandas and Matplotlib and NumPy in combination, how they can actually play a very important role in analyzing a very large real data files. Okay, so I end this video here. I will start the next video right from this command, and will tell you what is happening, what is this group by command. So hope to see you in the next video. Okay, in the last video we were discussing this COVID-19 file, and we reached here, but we didn't use this sklearn imputer. We just used the fill na function of data frame. Now let's discuss this group by command, or a query in Pandas that is much more feasible. Let's say our goal is now, for example, if you go back to Jupyter, if you see your data df.head or all, that's a df.head, let's say 10 records. If you want to see that, there are so many records, let's just see 10. Let's say what you want to do is you want to just see how many total confirmed cases are there in each country, regardless of their date. And for example, you want to just see all the confirmed cases, all the deaths, and all the recovered cases in each country for all the dates and for all the provinces combined together. One way to do that is to write a group by command. For example, let's say df2 equals df dot group by, and in group by what you see is for what kind of columns you want to group all this data. So for example, you want to group by country, so that's your grouping. Now after grouping, what do you want to see? What kind of for example, the values you want to see, because now you're grouping. Well, after grouping, I really want to see, because date is gone. Once I group all the dates, they are grouped together, all the provinces that are grouped together. So what I really want to see is just the country. And I want to see the confirmed cases. So pick all these records, confirmed, and then I want to see deaths and recovereds, for example. If I want to, deaths, and let's say then I want to see the recovered cases, RE, and just I want group all the countries together, group all these things together, and add all the records under each country. So sum all of them, and maybe we want to reset any index if it is there. So for example, reset index, so that thing. So after this query, for example, this group by query, what will happen is this df2 will contain a summary of the data with respect to each country and the total. For example, in this particular country, the total confirmed cases are these, all the confirmed cases till now, and the deaths are these and recovered as these for this country. For each country now, each country is describing. Australia, for example, till now, Australia has total these confirmed cases, these total deaths, and these are recovered cases, and so on. So that is if we want to group all these with respect to country. What if we want to group all these with respect to country and then date, for example? So first we want to group them by country, so country, and then for each country display all the dates, and then do the same stuff. The query will stay almost the same. A group by command will stay almost the same, with one kind of let's say we want to first group by country. Once it is grouped by the country, then I want to group them by date, and now I want to see all the results in the form of I want to see the date as well. And what will happen now is for each country, its trend with respect to all the dates that will be displayed here. So let's see df2 now, df2. So if you see df2 now, you can see, for example, this particular country it has just one record, then this country it has one record, then this country for this date has this record, for the same country another date has same record, and all the date is also sorted. I mean, now you can see all the records in a very incremental way. So that may give you a very good look and feel of what is happening. Or for example, another thing, what if you want to, for example, find out all the records, you just want to find out all the records. Let's df3 for which the confirmed cases, for example, the confirmed cases are more than 100. Let's find out all the records. Let's just pick all the records for which the confirmed cases are larger than 100, and let's copy all these records, just those records, in this. So if we do that, we have df3 available, and we have df3 this. I mean, these are just the records in which the confirmed cases are for sure larger than 100, just those. Yeah, so we can do, I mean, a lot of data analysis, the real data analysis, a lot more. I've just shown you a very small snapshot of what we can do with Pandas on the real data set. I mean, there is a lot more that we can do with this Pandas library on real data sets, on multiple data files, combining them together, joining them together, seeing their correlation, a lot of stuff. And this Pandas really is a very, very fancy and very high-level library, very high-level package to work with data. So due to time limitations, I'm just ending this Pandas here, although there is much more to explain in that. But in the next video, we will be jumping towards Matplotlib. Just we will see some functions of Matplotlib, and we will see very briefly how can we plot, how can we analyze data using visual graphs or stuff like so. So that sometimes this visualization of different attributes of the data give very good insight to the data. Wherever possible, if the visualization is possible, if the data dimensionality in a way, or the visualization techniques are in a way that you can visualize the trends in the data, that gives you much better insight than the numbers or statistical results. But it completely depends in what situation you can visualize the data. There are situations, high dimensional data, for example, is not always visualizable. So in those cases, the statistical results or the numbers may play a more important role. But in many cases, visualization give a very good initial insight into the data, and the design process can become very, very fast if you know something about the data. Whether you get that information by visualization or by other statistics or whatever. So in the next video, I will be just explaining some very few functions of Matplotlib, and then we will be exploring the same file, and we will be doing some stuff using the plots and Matplotlib, and seeing the trends of death rates, seeing the trends of, I mean, we will be playing with this file a bit more using Matplotlib as well. So hope to see you in the next video. Okay, in this video, I'm going to discuss Matplotlib, a very powerful package for plotting graphs and scattered plots, line plots, and 3D plots, and plots on the globe and whatnot. I mean, very, very powerful tool. The most important module in this Matplotlib, or the most popular module, or the most used module, is pyplot. So we can import matplotlib.pyplot as PLT. Another way of writing the same kind of stuff is we can write like from Matplotlib import pyplot as PLT. So either way is fine, whether we write this as a dot notation or that one, that is fine. So NP is for NumPy. So let's create some points. Just make our first plot. Let's make some points starting from 0. Let's say all the points starting from 0 till 10, and let's create 1,000 points in between. One way to do that is to use built-in function or a method in NumPy, which is linspace or linearly spaced points starting from 0, ending at 10, and there are 1,000 of those points. Let's say this is our x and this is our, let's say, y, which is np.sign. This sign function is actually will apply element by element on this NumPy array, and then this plt will actually plot x comma y, all the points in front of you. So let's go to Jupyter Notebook and actually see this Matplotlib in running form for the very first time. Oh, we have seen this Matplotlib when we saw np.random, we plotted a histogram. Wow. So this is not the first time. We actually have seen this once before. So import matplotlib.pyplot as plt. That's your import command, for example. Now plt is available. Let's say x is np.lin space. Let's say start from 0, go to 10, and generate, let's say, 1,000 points. Let's say that's your x. Y might be your np.sign x. Let's say that's your y. And then what you do is you say, okay, plt.plot x comma y point by point, and then you press shift enter. That's it. Oh, this plot is there in front of you. That simple. I mean, that simple. Can you imagine? This is that simple. Yeah, this is that simple. So I mean, plotting, this is a line plot, for example. If we want a scatter plot, we can say, okay, plt.scatter. There is a scatter function that allows us to plot all these in points form rather than these line form. These are a lot of points. That's why you're not seeing these scatters. So let me take this x as fewer. Let's say let's take x as let's just take few points. Let's say just 30 points, and let's see the corresponding 30 points. Remember the indexing of NumPy arrays? I'm just using that. So now use the scatter plots, and you have this. Oh, that's scatter. Maybe we want to use, let's say, start from the very beginning, go to end, and pick every, let's say, 10th point, and do the same with y, just to see a plot in a better way. Just sample some points. So that's the scatter plot. It is just like, I mean, the points and so on. It is not a continuous plot like the line plot. It's a scatter plot. We can annotate this scatter plot. We can change these colors to any color we want. For example, we can have a property. For example, color is equal to, let's say, red, and everything will become red. Yeah, so that's red. We can have, I mean, we can label it, we can X label it, we can Y label. There are a lot of properties. But the main point is, plotting is that simple. Plotting is that quick using Matplotlib. So yeah, this Matplotlib is really, really powerful. We have just seen a snapshot, just a plot function and a scatter function. There are a lot of properties to be set. There are a lot of things to be considered, and we will see actually one lengthier code on this COVID-19 file, and we will actually analyze the death trends and the confirmed trends and some trends that and we will plot them and see the trends really using Matplotlib. So but before that, let me show you that if you call this plot multiple times, for example, maybe with different colors, then you will be having a lot of curves on the same plot, for example. So for example, let's see plt.plot x comma y, let's say with color, let's say color equals to blue. You can write blue the whole, or you can write just b, that's fine. plt.plot x, and let's say np.cos x, and the color you are interested in, let's say the color is let's say green, and that's perfectly okay. And that will give you two plots in the same figure, sort of, and you can just good to go. Well, yeah. So that more you can, for example, you can plot with a green color, and you want the solid line, or you want, for example, cyan color in a dashed line, or you want a dash and dot black line, or maybe you want a completely dotted line in red color. So there are several things that are available in Matplotlib. This is just a very simple snapshot, and I have given you a very quick start. And actually, the whole point is using MATLAB is that quick. I mean, you have your data, you just plug in their data, you just call the plot function, and you're good to go for analysis. Okay, in the next video, we will actually walk through the COVID-19 data set, and we'll actually analyze the trends and the death rate trends for each country individually, and then we will see the death confirmed and the recovery trend of the overall world till the 16th of March, till the date the data is available. So next video will be actually you will see the running form of Pandas and Matplotlib together. So hope to see you in the next video. Okay, I already have shown you the COVID-19 file, and here I have a notebook on that uses Matplotlib and Pandas to find out the deaths, confirmations, and recovery trends using different plots. So let me import all the packages that I need. I need a pyplot function from Matplotlib. I need Pandas somewhere. I need NumPy. And I'm using a simple imputer here for missing values. So let's run this. Let's run this command. And yes, everything is imported. Now let's load the data that I have shown you earlier. The data is available now. And let's run this thing that is the first 50 records. Yeah, remember that? Yeah, so that's the data that is available. If you just want another view of the data, that's the data file, which is COVID-19 file, and it has observation date, province, country, last update, confirmed to date, death to date, and recovered to date for each country and for each province individually. Okay, great. So that's what we have now. What we can do is, now let's drop the serial numbers and last update using in place and rename the columns that we did already in a previous video as well. Let's convert the date into the Pandas built-in date frame. Okay, let's use the scikit-learn imputer, sklearn imputer using the constant strategy. There are a lot of strategies there. Let's use the constant strategy. And this pd.dataframe impute.fit transform, that will help imputing all the missing values with a constant strategy imputer. So that's there. Okay, next let's apply this group by command and group all the records using country for each country, and for all the dates let's sum all the records, let's sum all the values of recovered, deaths, and confirmed using this. But now let's first country and then all its date, then the second country, then all its dates, and so on. We have seen that in one of our previous videos, just running that again just for a double check. So that's what the data state is. So country 1, all its dates, country 2, all its dates. So this country has a lot of dates, then another country, and so on. Next, let's see how many countries are there in total, how many unique countries are there. So what I do is I find the column, I actually pick the column with country and call a unique function on that, and that gives me all the countries without repetition. And I just compute the length of countries, tell me how many unique countries are there in this data file. There are 171 countries. So now my goal is, for each country I want to see what is the trend of with respect to the date, as the date is moving from the first day till 16th of March. What is the trend of death patients, what is the trend of recovered patients, and what is the trend of confirmed patients as the date moves on. So because we have 171 countries, so let's loop over each country again and again. Let's loop over. What we do is, for IDX in the range of this, that's a loop, you remember that. And what I do is, let's find out the indices where the country is like this. Let's find out the index, all the indices where the country is like that. Then what I do, I make a scatter plot that with starting from this and that. I just pick the confirmed cases, and all the confirmed cases for this one country, I just pick those, and I do that using this scatter plot. Then I use another scatter plot just to get all the recovered cases. Then I do another scatter plot to get all the death cases. And then the title of my figure becomes the country name. The X label is the days since the first suspect. The Y label is the total number of cases. The legend command actually will be there that will show what each that is. So these kind of labels that are we writing here, they will appear in the figure. Then we force them to show that in each iteration, show the so this will show the trends of confirms, recovers, and deaths for all 171 countries one by one. So if we run this command, we'll be having 171 plots in front of us. Let's see all of those one by one. So yeah, so this is for the country. It has just one such thing. This is for that. This is for Afghanistan. As days moves on, the confirmed cases that are written in blue, they are moving up. These are the number of cases. These are the number of days since the first day. And the green is the number of recovered cases. For Albania, that's the trend. For Algeria, that's the trend. I mean, these are each and everything is a separate. That is for Argentina. That is for America. This is for America till the 16th March, by the way. Today, the news says that America is really in a dangerous position. Anyways, that's for Australia till the date. We have the data that is for Austria. Yeah, so these are all the trends for all the countries. You see, I mean, the Matplotlib, how powerful that is. Although I walked through this code very quickly, but you can see this video again and again and check how that happens. Yeah, so that's what this is for Finland. Oh, Finland is also in trouble. So France, okay. So that is for Germany, and yeah. So all the countries that are available in dataset, they have these kind of plots. This is for Hong Kong, and this is for India, and this is for Italy. So Italy is yeah. So that's it. So that is for each country individually. What if we want the overall trend, or the overall confirm and the deaths and the recovered trend for all the world together? So what I do is I group all the data with date. So I pick the first date and add all the records, then the second date for all the records for all the countries and so on. And then I plot the trend using the scatter plot again, confirmed, recovered, and deaths for all over the world, and see the trend where the world is moving. So that's the trend of the world. As the days are going on, these are the death trend, that's a recovery trend, and that's a confirmation trend that is moving on. Although I walk through over this notebook, the notebook will be available to you. I walk over this notebook very quickly, but the goal was really to show you I mean, that was a file. May not be that informative if you see that in Excel, but now it makes much more sense. When you see these plots, you know what is happening and you have an insight in the data. And later on, we may want to predict, we may want to make predictions, and the next date, what is going to happen, we may want to predict using this plot or using some machine learning library like scikit-learn or TensorFlow or something like that. Okay, so that's it. I can talk much more about Pandas, NumPy, Matplotlib. There are so many other data science packages, very important packages. One of those is sklearn. That is for machine learning, basic machine learning. Then there are other packages like TensorFlow for deep learning, PyTorch for deep learning. There are a lot of packages with a lot of specialities in data science and stuff. I just discussed a few of those, the most important of those, to manipulate the data, to make predictions, to make classification or regressions, one way is to go to sklearn or scikit-learn, and if the data is huge and you have a lot amount of data and you have good expertise over deep learning, then you should go to either TensorFlow or PyTorch. These are the Python packages that are available for predictions, classification, regression, and a lot more. But either way, whether you are going to use scikit-learn, whether you're going to use TensorFlow or PyTorch, either way you have to use Pandas, NumPy, and sometimes Matplotlib to pre-process the data and to make the data ready for these kind of libraries to perform predictions, either in the form of classification or in the form of regression. So so this whole course was about for beginners who want to learn Python. Specifically, I discussed a lot about Python in general. Then I spent some time, not a lot amount of time, sometimes on exploring the data science packages as well. But I mean, there is no end. We can explore more. We can talk about the packages more. We can talk about other features of Python more. A lot of input formatting, output formatting, modules, packages, standard template library, file handling, internet access, database. This is a whole universe. I have discussed a few things for beginners, but these few things were very carefully selected for data scientists. If you have this course available to you, as you have gone through all the course, you now have a very, very good understanding, and now you can move towards further advanced courses towards data science, and you will be ready to implement the concepts in Python using the packages I have discussed so far. So I thank you all and good luck.